In this video, we're going to be talking about section 4.1, part 1. We've already spent quite a bit of time talking about radians compared to degree measures, so I'm going to go through this pretty quickly. As you know, 1 radian has been defined as the measure of a central angle theta that intercepts an arc, I should say arc, S in length, and it happens to be the same length as the radius. Now, written down, it's a little awkward, but visually, we can kind of see what's going on here. So if we have a circle that has a radius of r, and we take that length of r, which goes from here to here, and we then lay that out along the circumference of the circle, then it would stretch to approximately here. And so the length of the radius and the length of the arc length are the same. This angle that is formed, that's created by this, right here is theta, that is defined as a single radian. So the other way we know how to define a circle is that there are 360 degrees in a circle. I want you to realize that's about as arbitrary as anything, right? That is back from the ancient times when it was determined that there were about 360 days in a year. And so that kind of measurement has carried over from centuries and hundreds and hundreds of years. And that persists today, and why we use degrees. Radians, while it seems like a strange way to define an angle, is actually very precise. And we'll talk about some of the ramifications as we go. So this is the size of a radian. If we were curious how many radians make up a circle, then we wrap those radians around, right? There's approximately another radian. And we do another radian, which is approximately here, which is what this other image is showing you. And we get all the way around to here, which is 6 radians. And obviously another 7th radian would go past a full circle. So one circle is not a clean number of radians. It is 6 and some change. So why is this a better method? Well, if we think about this, the arc length that we're talking about here, r, if we wrap all the way around a circle, then how many r's go around one circle? In other words, we know that a circumference is equal to 2 pi r. So how many r's wrap around a circle? And the answer is 2 pi of them. Circumference is 2 pi times the radius. So how many radians are in a circle? The answer is 2 pi. Because again, a radian is just defined to be this angle, and however many of these radiuses fit around a circumference is the same number of angles that would fit around a circle. So, long story short, we know that there are 2 pi radians is equivalent to once around the circle, which is equivalent to 360 degrees. All right. And by determining this, we have now figured out a conversion factor. So we need some way of converting from one unit measure to the other, just like we need a way to convert from inches, to centimeters, from metric to standard. We need a way to convert from degrees to radians. And one complete circle is the way we do that. So 2 pi radians equals 360 degrees. Remember, there's no unit for radians. The pi is not a symbol. It's not a unit. It's the number 3.14, right? It is the approximate number 3.14. I can divide both of the sides of this equation by 2, giving us pi is equal to 180 degrees, which tells us that a half a circle is 180 degrees and half a circle is pi radians. And by establishing that, we can create a very helpful tool to do conversions. What I mean by that is if I wanted to divide this side of the equation by pi, I can do that as long as I do the other side. And I do the math here, and that simplifies out to be 1 equals 180 degrees over pi radians. So we know that 180 degrees and pi radians are the same thing. And when we divide them by each other, that equals 1 because you're dividing the same thing by itself. If instead we wanted to divide the other way, we could do that. So if I divide by 180 degrees, 180 over 180 is 1. And now I get the statement pi radians in 180 degrees. Those are the same thing. They both equal 1, so you can write them either way. All right, we'll come back to this and why that's useful in just a moment. A couple of quick definitions to remind us and to kind of think about in terms of radians. We know that supplementary angles are two angles whose measure add up to 180 degrees, or we could be talking in terms of radians, which would be pi radians. Complementary angles are two angles whose measures add to 90 degrees, or pi over 2 radians. All right. All right, so to get started today, we're going to really think about how to convert from radians to degrees. All right, now with the work that we've done, we can do some of these very simply, but I want to make sure that we understand how we can use the conversions that we just discovered a moment ago. So these are all in radians, so there's no units attached to them, but if you want to, just to kind of keep it straight in your head, if you want to write the word radians next to it, that would be fine. So if I want to convert pi over 6 radians and I don't know the answer already, then I can use one of my conversions above. So I've got these two statements that I circled. Okay. So if I want to turn radians into degrees, I'm going to use a little bit of unit analysis. So pi over 6 radians, I want the radians to disappear, and I want degrees in their place. So only thing I can do here is multiply by the number 1, but 1 can take many forms. For example, we know that in pi radians, there are 180 degrees. So by multiplying it this way, our radian unit on the bottom cancels radians on the top, and we're left with something that's in degrees. And now it's just up to us to do the rest of the math here. And I know that pi over 6 times 80 over pi, the pi's cancel, and 180 over 6 is going to be 30 degrees. Now, we already know, because we spent all that time on the unit circle, we already knew that pi over 6 was going to be 30 degrees, and we knew that because we know that pi is 180 degrees, so we can just kind of replace the pi with 180. 180 divided by 6 is 30. So I went through a lot of trouble here, and you might be wondering, well, why am I doing that? I'll make that clear in just a moment. Let's go to part C. Again, lots of ways of thinking about this because you already have prior knowledge coming in. We know that pi over 4 as a unit is just 45 degrees. And so this is saying you have 5 of those 45 degrees. So we just need to multiply 45 times 5 and we'll have our answer. Or instead of that, we could just realize that pi is 180. And so that would be 5 times 180 divided by 4, right? But if you walked in with no prior knowledge, then what could we do to get the answer? We could use unit analysis. Again, this is in radians, and I need radians to be replaced with degrees. So if I do 5 pi over 4 radians times, I need radians on the bottom, so pi radians over 180 degrees. Radians cancel with radians, pi cancel with pi, and I'm left with just what I said a second ago, 5/4 times 180, which is going to be a pi over 4 beyond 180, or 45 degrees, so that's going to be 225 degrees, I believe. Okay, so why wouldn't I always just do it the easy way? And the answer is because of part B. What are you going to do on part B if you don't have a system? Because I don't have a pi to replace with 180. I just have a 1 radian. And if I don't know what to do, then I'm stuck. So we practice kind of methods. We may not use those methods all the time, but we have them in our back pocket if we need them. So I'm going to use the same method you've seen me do. 1 radian times the number 1, but I'm going to do it in the form of 180 degrees over pi radians. That's just the number 1. Radians cancels with radians. I'm left with an answer of 180 degrees divided by pi. And if I want to turn that into an approximate answer, like something I can actually measure on a compass or, a protractor, then I would grab my handy calculator and I would get that 1 radian is approximately equal to 57.29, call it 6 degrees. And so 3 radians, again, I don't really have a way of moving forward if my only method is to replace pi with 180. But I know that I can get the answer by doing 180 degrees divided by pi. And so it's just going to be 3 times 180 divided by pi, which of course is just going to be 3 times the answer we just got. And so the answer to that is going to be approximately equal to 171.887 degrees. All right. In class, I would now have you guys do these on your own. So please pause the video and give that a shot. Same thing, convert from each angle measure from radians to degrees. And do it in whatever way is most efficient for you. All right, so in part A, pi over 10, I know that pi is just 180. So the easy way to do this is to turn pi radians into 180 degrees. So this just says 180 degrees divided by 10, which is going to be 18 degrees. 5 pi over 6, I'm going to use prior knowledge, and I know this is just saying we have 5 pi over 6s, which is 5 pi over 6 is 30 degrees. And so that's 150 degrees. I'm going to skip 4 for a moment. I'm going to go to 11 pi over 4. I'm going to do this by realizing I have 11 pi over 4s. But really, I'm going to think about the fact that if I had 12 pi over 4s, I'd be at 360 degrees. Nope, hold on. Brain shut down. I was thinking about something else. Let's try this again. I think I'm right, but I was still thinking about something else. On a unit circle, let's see, 4 pi over 4 brings me here. 8 pi over 4 brings me here. 9, 10, 11 pi over 4. So 11 pi over 4 is right here. So how much is that? Well, we went around the circle whole time and then another 135 degrees. And so it'd be 360 plus is 135, I think. Or probably what I would do now on second thought is I would just do 11 times 45 on my calculator. So 11 times 45 is 495 degrees. All right, but on part C, none of those methods are going to really get help me get the answer. So I'm going to fall back on just using my conversion. So 4 radians multiplied by the number 1, but the number 1 in the form of 180 degrees and pi radians. Radians that we don't even have written down cancel out. I'm left with degrees. And so the answer is whatever 4 times 180 is divided by pi. And the answer is approximately 229.183 degrees. All right. And now let's go the other direction. Let's convert each measure from degrees to radians. So using prior knowledge, I can kind of figure this out on my own. I know that, for example, 60 degrees is pi over 3. And I know there's 460 degrees into 240, so I could do it that way. Or I could just use a true conversion, and I could say, I'm going to take 240 degrees, I'm going to multiply it. This time I need degrees to cancel. And so my 180 degrees needs to go on the bottom, and my pi radians need to go on top. So degrees cancel out. I'm left with radians. My zeros cancel out. I've got 24/18 with 6 goes into both of those. I get 4 pi over 3. Remember, no unit on radians, so you can leave it just as 4 pi over 3. All right, 50 degrees. That's not one that I know. It's not our known system, so I'm just going to convert again. 50 degrees times pi radians over 180 degrees. Cancel, cancel. 0, 0. 5 pi over 18. And then this is a weird one. Pi degrees. So we're talking about 3.14 degrees. We're not talking about 180 degrees. It's not pi radians, it's pi degrees. Now, if you're going to run across this in nature, no, absolutely not. This is just us making sure we're paying attention to what we're doing and trust in the process. So I have no idea what to do here, so I'm going to trust in the system, and I'm going to simply multiply by pi radians over 180 degrees. Degrees cancels with degrees. Pi's do not cancel. I'm left with pi squared over 180, and this would be in radians. And if you want to know, like, what is that, then we would just do on our calculator. Pi squared is 9 something probably, and 9 divided by 180. Okay, think about that. It's not very big, right? This is about 3 degrees. That's a very small angle. Okay, let's keep going. Find the complement and the supplement of each angle. So, when in general, the rule is if you are given a question in radians, do your best to think in radians, do the math in radians, and certainly answer in radians. And then the same is true of degrees. So, but try to do this all in radians. I know that complementary angles add up to 90 degrees or pi over 2. So complementary would have to be then I'm going to take my total of pi over 2 and subtract what I have as an angle, pi over 3. Now, I already know if I convert that pi over 3 is, what, 60 degrees? And so we're talking about an answer of 30 degrees here, or pi over 6. But we can also just trust in the math. I need a common denominator to subtract fractions. So I'm going to multiply by 3 over 3, giving me 3 pi over 6, minus, and then 2 over 2 gives me 2 pi over 6. And just as I suspected, I am left with an answer of pi over 6. So the complement of pi over 3 is pi over 6, and vice versa. The supplement, we would just take our angle and subtract from 180 to get what's left over. Or in our case, we're going to take our angle and subtract it from pi. So pi minus pi over 3. I'm going to turn pi into 3 pi over 3 minus pi over 3, and I get 2 pi over 3. And again, that makes perfect sense, right? If I've got an angle of pi over 3 right here, that's 60 degrees. And then 1, 2 more pi over 3s would make a total of 180. The complement of 3 pi over 4 does not exist because 3 pi over 4 is greater than pi over 2. The supplement would simply be pi over 4. Because how many more pi over 4s to get to 4 pi over 4? A pi over 4. You could do the math and subtract, but honestly, just thinking about it gets you there quicker. All right, we're getting close to being done. A couple quick definitions. The initial side of an angle is the starting position of the ray before we rotate it to create an angle. The terminal side is where the position of the ray is after we rotate. Almost every time in this class, we will always be, when we're talking about angles, we're going to be thinking of a rotation that has a vertex, a rotating point at the origin, and where the initial ray is going down the positive x-axis. So that is always going to basically be my initial side. And then I'm just going to rotate it around, and wherever I stop is the terminal side. So if I open this angle up and I stop right here, then that would make my terminal side. Okay. Now, we can start and stop anywhere we want, but if we're talking about standard position, which we almost always will be, we're talking about it looking like this, starting in the same spot and then ending where we end. Okay, and then that brings us to the final thing for today, which is coterminal angles. Coterminal angles are angles that begin and end in the same place, same initial and terminal sides. So what I want you to imagine is like this angle looks to be about 2 pi over 3. So let's call it 2 pi over 3. Now, if I close my eyes and you drew this or rotated to that spot, and I open my eyes and we're done, I don't really know how you got there. I can assume that all you did was open up 2 pi over 3. But especially if I don't have this little arrow here, right? All I know is this picture. I don't know what you did. For all I know, you might have just done the quick, easy way and rotated it to here. Maybe you went in the negative direction and rotated to here. Either way, we would end and begin at the same place, and I would have no idea how you got there. So that's coterminal angles. They begin and end the same place, and how we get there is less important. And for that matter, not only could we have gone forward or backwards, we also could have gone maybe around many times. Like I could have just let you rotate and rotate and rotate, and then I open my eyes and there you are. I don't know how many times you rotated. Maybe you did 100 times. Maybe you just did one or just that little spot right there. So coterminal angles. So let's go ahead and think about that being 2 pi over 3. And let's find 2 positive coterminal angles and 2 negative ones. So if I've opened up to 2 pi over 3, let me recreate this picture here. Then from standard position, I have ended right about there and opened probably like this, 2 pi over 3. All right, so what's another angle that does the same thing? That would be me maybe just keeping on going past 2 pi over 3 and going all the way around again. Or in other words, one answer would be to do 2 pi over 3 and then add a full circle, which is 2 pi. Often when I'm doing this math, I'll just not write down 2 pi. I'll do the conversion to a common denominator in my head. So what I would really think about doing is not adding 2 pi, but adding 6 pi over 3, which is 2 pi. So a theta of 6 pi plus 2 pi, 8 pi over 3, is going to begin and end in the same spot. 6 pi over 3 rotates me to here, and then I've got another 2 pi over 3 that gets me to there. And if I wanted another one, then I could do the previous answer, 8 pi over 3, and add another 6 pi over 3. And that would be 14 pi over 3. All right, now if I want a negative coterminal angle, then instead of opening this direction, I'm going to open this direction. So I don't usually do this part very mathematical. I just sort of ask myself, how far will I have to rotate to get to there? And it would just simply be, there is no word I can think of at the moment that is sort of like supplement or complement, but that means 360 degrees, but that's what we need. We need the other angle that'll add to be 360. But I know that if I go all the way around to here, that's 3 pi over 3. And if I go one more, I'll meet up with that one. So this angle is going to be negative 4 pi over 3. Okay, so if I start in the standard position and I rotate around negative 4 pi over 3, I'll end in the same spot as if you just rotated 2 pi over 3. And if I want another angle, then I would just take that negative 4 pi over 3 and I would add another negative 2 pi, or more handily 6 pi over 3. So that would give another angle of negative 10 pi over 3. Okay. If I want another one, I could just wrap it around again, add another negative 6 pi over 3. All right. With practice, this should all become quite simple, I hope. If you have any questions, please come talk to me.